Hi, welcome to Lesson 22J, Independent Events. The goal of today's lesson is to learn how to solve a variety of probability problems involving independent events. Well, along with independent events, often occurs or is involved conditional events, conditional probability. So we're going to take a look a little bit of the notation and then see where we can go from there. Okay, so first of all, independent events are two events where the occurrence of one of those events does not affect the probability that the other will occur. Okay, so for example, if we are flipping a coin, say we're flipping a coin twice, the fact that the coin turns up tails the first time has no bearing on the probability that it has a 1 in 2 chance or 1 in 2 probability of turning up tails the second time. If we were, for example, another example of independent events is if we were to flip a coin and it lands in heads, and then we roll a die and it rolls a 5. Well, the fact that the coin turned up heads has no effect on the probability that the die will turn up a 5. Okay, so those are independent events. If we were, for example, to choose a marble from a jar and flip a coin, those of course are independent events. As well as choosing a card from a deck of cards, replacing it, and then choosing another card. By the virtue of us replacing that card, the total number of cards remains the same as from the first draw. Therefore, the probability of choosing, say, a suit, like a spade or something, will remain 1/4, just like it was in the first drawing. Okay, so there's all kinds of different examples of independent events. So, along with that, suppose we've got also conditional events, conditional probability. So here I've got a Venn diagram, we've got event A and we've got event B. So the condition or the probability that event A will occur, given that event B has already taken place, well, we can look at that as, well, out of all of the probability of event B taking place, so we know that event B has already occurred. Out of all of that probability, what's the probability from there that A occurs? Well, the only place where they overlap is right in here. Okay, so that would be the intersection of event A and B. Okay, so the probability that A occurs given that B has already occurred, well, we know B has already occurred, so we know that probability, and then from that probability we see what the probability that A occurs, and that's the intersection of A with B. Likewise, if we have the probability of A given that B does not occur, well, again, we're saying that B is not going to occur this time, the complement of B. So the complement of B is everything outside of B. So given that this happens, what's the probability? So given that B has not occurred, so everything outside here, what's the probability that A does occur? Well, from all of this outside of B, this moon-shaped part of A is the part that is also part of that subset of not B, or the complement of B. So that's the probability of A intersect B complement. So now if these are independent events, and this is the big thing also, if these are independent events, whether B occurs or not, then the probability of all this is still just going to be the probability of A occurring. So Suppose we say the event A is flipping a coin, and we're looking for the probability of it being a head. Then whether the event of B being rolling a die, for example, whether it rolls a 5 or not, so rolling a 5 or not rolling a 5, the probability of flipping a head is still going to be the same. It's still going to be just the same probability as just flipping the head or flipping the coin on its own. Okay. So now from these we can this is probably what we'll see more often. We can then multiply both sides by the denominator, so the probability of B multiplied by the probability of A given B is equal to the probability of A intersect B. So the probability that B has occurred multiplied by the probability of A occurring after B has already occurred, which we just occurred over there, that's going to equal the intersection of the two. Okay? And the fact that these are independent events, well, if this side here is equal to this side, then that means that this must equal the probability of A. So we can replace this with the probability of A. Therefore, the probability of B multiplied by the probability of A equals the intersection, the probability of the intersection of A and B. Therefore, now we have a test also. If we're given perhaps the intersection and we're given the individual probabilities, we can now take these two probabilities, multiply them together, and check to see if they do equal the intersection, the probability of the intersection. And if that is the case, then we've got independent events. If this does not equal each other, then the events are not independent. Therefore, they would be dependent. Okay, so let's take a little example here, and I'll just set this up. Okay, so suppose, please forgive my crude illustration here. Suppose we've got 2 green marbles and 3 red marbles in a bag. We can't see in the bag, we just have to pull marbles out of the bag and check what kind of probability we would have. So the probability of getting a green marble, so we've got a green marble that we've pulled out. The probability of getting this green marble is, well, there's 2 green marbles out of a total of 5. So the probability of getting green is 2 out of 5. And then the probability of getting red, well, we've got a red marble that we're just pulling out now. And the probability of getting that red marble, well, there's 3 red out of a possible 5, so that's the probability of 3 out of 5. So now what's left over, once we pulled that green marble out, if we don't replace it, then we've got 1 green marble left and 3 red marbles. If we've pulled out the red marble, we still have the 2 green marbles left over inside the bag, and now we've got only 2 red marbles. Okay, so now that the probabilities, if we were to draw another marble out, the probabilities will change because we've taken a marble out and we've removed it, and so therefore we'll get a different probability. Now this is, of course, even though we're looking at 22J independent events, this is an example of dependent events, but I'm going to show you how this all ties back into this formula here. So then I'm going to check out, so I can either, there's two possibilities again here, so I can either pull out another green marble, and the probability of pulling out a green marble out of this, the remaining set, is instead of 2 out of 5, now it's going to be 1 out of 4. And the probability of pulling out a red marble is, again, not 3 out of 5, it's going to be 3 out of 4. Okay? And then what happens here is, when we pull out a green marble here, there's going to be 3 red marbles left over. And if we pull out a red marble, there's going to be 2 red and 1 green left over. Okay? So now, we've got, if we chose we pulled out a red marble first, again we're going to have 2 probabilities. So after we choose the red marble, if we choose a green marble, the probability of that is going to be 2 out of 4, because there's 2 green marbles out of a total of 4. Or if we choose, or not choose, select a red marble, then the probability of that's going to be 2 out of 4, because the 2 red out of the total of 4. And then what's going to happen here is, here we're going to be left with 1 green and 2 red, if that happens. Or in this case, if we choose another red here, we're going to be left with 2 green and 1 red. Okay, so those are how the probabilities will stack up. Okay, so notice that the probability of choosing a green marble after choosing a green marble and not replacing it is now going to be 1 out of 4. The probability of choosing a red marble after choosing a green marble is going to be 3 out of 4. Even though we had 5 marbles to begin with inside this bag. Sorry, terrible drawing. That the probability has now changed because we took 1 marble out the first time. Again, if we chose the red marble first, then the probability of drawing a green marble after drawing that red marble is going to be 2 out of 4, as opposed to the 2 out of 5 of the initial probability. And then again, for the red marble, if we choose a red marble after the first red marble was taken out, that probability will be 2 out of 4. Okay, so now what if we were to say, okay, well, what's the probability of drawing 2 of the green marbles? Well, the probability is going to be, well, 2/5 for the first drawing of the marbles, and then 1/4 for the second drawing, and then we just multiply that across to get 2 over 20, which simplifies to 1 out of 10. So the probability of drawing 2 green marbles in a row from a bag of 5 marbles is going to be 1 in 10. Okay, so here's where we tie all these things together. So we selected, we didn't choose, we selected a green marble at the beginning. And now, so let's say that is event A. So event A is selecting a green marble. Then event B is choosing selecting a second green marble. So here's where the notation comes in. So the probability of selecting a second green marble, given that we've already selected a green marble, is going to be 1 over 4. So when we multiply these two probabilities together, we're actually multiplying the probability of selecting a green marble first, multiplied by selecting a green marble, given that we had already previously selected a green marble. So then when we look at it in this way, we can go back to the beginning. Now I know it's the letters are kind of reversed around here, but the same sort of thing occurs over here. We've selected one item, and then we follow through and we select another item given that we had previously selected that item, and that gives you the intersection of the two probabilities. Okay, so that's a little bit about conditional probability and independent events. And I know this is dependent, but it also comes into play with conditional probability, and we have to kind of understand both independent and dependent probabilities as well, or events. So what I'd like you to do, please, is before we get to class tomorrow and look at the examples in class, I'd like you to look at example 26 on page 601, and then follow that by example 27 and 28 on page 602, and then take a quick glance at exercises 1 through 3, 5a, and 6 on page 602. Okay, but remember, we'll take a look at a few examples tomorrow to help you wrap your head around this. Okay, well, thank you very much for watching, and we'll see you in class.